Hello, welcome to Module 1, where we're going to cover the chemical and physical properties of matter. However, we're going to start with talking about what's chemistry. What is chemistry? You look into that image right there, what do you see? You see fire, right? What's it take to make a fire? Is there a reaction going on there? Is it chemistry? What do all fires require? I'm not going to answer all these questions right now. We're just going to kind of talk about things. You look in that image. Some of you folks are probably baseball or softball players, right? What are those $300-400 bats made out of? Is that chemistry? Does it involve chemistry? Do the bat makers hire chemists and material science folks? Is chemistry important to that endeavor? And there, looks like Tylenol there to me. The pharmaceutical companies out there, do they have chemists working for them? Is that chemistry in action? Something for you to think about and look at the different areas that we're talking about here and chemistry. You go right there. What's Roundup? Roundup's a herbicide, right? Does it involve chemistry? Should people be aware of the chemistry of Roundup? What are some of the controversial issues in the world today because of Roundup? We'll go there. Some of you folks probably like to golf. Good set of golf clubs cost a pretty good amount of money, correct? What are those golf clubs made out of? Is that chemistry? Did it involve chemistry in making those golf clubs? Something to think about. Some of you folks probably like to bike, whether it's on a like the Heritage Trail in Terre Haute, or like go out west or down to the park south of Terre Haute and do some mountain biking. What makes a mountain bike that's a $1,500-2,000 mountain bike that expensive? What materials is it made out of? Does that involve chemistry? And then those of you that are beer connoisseurs, does that involve chemistry and the making of beer? Any beer makers out there know how you make a good beer? Just something to think about. We've looked at fire, baseball bats, Tylenol, Roundup, some golf clubs, bicycle, a mountain bike specifically, and beer. Do they all involve chemistry? Something to think about. So then, what is chemistry? Chemistry is the study of matter and the changes that matter undergoes. Can you start visualizing and understanding each of the examples we looked at there on the first screen? Have something to do with this? Okay. Why is it a good idea for all college students to study chemistry? If you take a look at all the different majors some of you guys are majoring in order and looking for a degree and a specific career, some of you can be looking at perhaps becoming a lawyer. How do lawyers get involved in chemistry today? Are there a lot of lawsuits involving chemistry and environmental matters? Nurses, do they need to know something about chemistry and the medicines and the drugs and the IVs and so forth? Think so. Environmental, we got the EPA and all kinds of agencies out there that's keeping us in environmental standards. Chemistry is pretty important in that area anymore. Medicine, as we said, with nursing, if you're going to be a doctor. Same thing with pharmacy, veterinary medicine. They administer a lot of drugs and things to dogs to prevent them, dogs and cats and other pets. Um, Give them things like HeartGuard. That's chemistry. Okay. And then when you're talking like polymers, cosmetics, and different materials and manufacturing, that's like I was talking to golf clubs and the baseball bats. You can call that entire area material science. And each one of those different industries going to have their material science and chemistry folks working on new and better products all the time. So hopefully you can see that there's a wide variety of areas that has some chemistry basis to them. Okay, so what we like to kind of push and get people to understand, we need a sustainable chemistry education for um, most students that are going through colleges, so as they can get a basis of chemistry for themselves. But it could also be for them to excel better in some of the careers they're looking at. Because like if you're going to go into medicine and you could be involved in medical research and looking for cures for different diseases, different conditions, and then or even studying drugs that you're developing new and better drugs to treat given conditions. Um, but you could also be one of the folks that's working on cleaning up this environment we live in and studying the ways that we can do that, and also holding some people accountable for the pollution and so forth going on. Okay, so sustainable chemistry is a responsibility that we have, and the only way that we can do that is through education. But on top of that, chemistry is a blast. I've had a lot of fun with chemistry. There's a lot of neat things you can do. There's a lot of dangerous things you can do, from um, firecrackers to you name it. I mean, chemistry's got a lot of bad flack in the world today, in the creation of plastics explosives and the different types of bombs and so forth that have been made. So you can go from one extreme to another. You can have chemistry to make a drug that's going to cure a very, 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 very bad disease, to someone that learns chemistry to making illegal drugs and methamphetamine and fentanyl and some of the problem areas like that. But I like chemistry. I like chemistry, and it's fun. Okay. I'm not going to spend a lot of time on this, but most of you have been through school and probably starting fifth, sixth grade or so. You start talking the scientific method. The scientific method is important in all research. And at all levels of science, you ought to know there is a process and a logical way of thinking and a logical way of doing research. Um, and it seems we make it a little bit more complicated all the time. But uh, some of the main things are in the scientific method is we learn to make observations. And we seem to be getting keener with that all the time, and with the cameras and the different tools that we use today. So we think about things and we ask questions. We develop hypotheses. That's the driving force, I believe, in the scientific method, because you're taking a guess at what's going on. Usually it's a logical guess of some sort. And then you develop and you test, and that's where we really get into things in chemistry, when we develop and test and we start looking at things going on, in which that's what you see here, testing. And then we develop theories and